Hello, everyone. This is your host, Casey Orr from the field. I'm actually streaming directly from Wellington, New Zealand. I'm actually in the AWS office. As you can tell from the piggy face, it's actually might be staring you down for the whole entire show. And if you've just been joining us from the previous stream, which is Howdy Partners, then I hope you stick around because this one's going to be a awesome stream as we are going to be starting a 5-part series on how to become a network ninja. Now, Ratan will give you more information about that soon. But before we do that, why don't we have a quick round of introductions? Imran, do you want to start off?
Cool. Thanks, Casey. So my name is Imran Sadiq. I'm one of the senior solutions architect working in our enterprise segment here in New Zealand. And so I will be presenting the session with my other colleagues today. So I'll pass you on to Imad. Let him introduce himself.
Hey, thanks, Imran and Casey as well. My name is Imad. I am a network lead, essentially a solutions architect here at Mercury in New Zealand. It's a utility company. I look after on network and essentially anything that looks like network and speaks like network, including cloud. That's me. So now,
Imran,
yeah. Sorry.
before you hand off to Ratan, do you want to tell people what Mercury actually does? Because we do have a international audience, and while Mercury means a lot to us, maybe not from someone in North America.
Yeah. Thanks, Casey, for reminding me that. So Mercury is a power utility company in New Zealand. We are one of the biggest company in New Zealand for power generation. So what Mercury does. So we look after. So in my role, I look after the network that is both on-prem and cloud. Cool. So thanks for that. Now I'll pass it on to Ratan.
Hey, Matt. Thank you. And look, it's great to have you here. I always say that I have been learning networking out of hobby or out of interest. Imad is a real, networking geek. I've had the privilege of working with you at Mercury, so I'm super excited that you have actually taken time to join us for this session, which is the first of the series that we're planning to do this year, which is about becoming a networking ninja. And just to give a little quick context that why we decided to do a series on networking. And I've been kind of thinking that, look, networking is really what has made cloud possible. I think you would agree with that, Imad, because you've been doing networking for a long time, even before cloud came, right? And so in many respects, networking has made cloud possible. And at the same time, I would say that it's the reverse is like AWS Cloud has also made networking more accessible, right? So as a developer, I would be kept at probably arm's length by some of the traditional network engineers from anything to do with networking, because I'm a developer, right? So they will say, don't touch anything to do with networking, you're gonna break it. Um, but gone are those days, because look, you know nobody can now say that I'm apps guy and I only do apps. I don't do database or I don't do networking, because the new world that we are living in is where you build and you maintain, right? You as a build team need to we have a concept in Amazon of two pizza team. So two pizza team is essentially a team which is building the apps. They are also supposed to be making sure that they are automating, they're looking after the network security. Every aspect of your application is something that you got to look after. So I would say that this is why it's absolutely must that in today's day, if you're a developer or an engineer or an architect, you got to have certain skill set or certain foundational skill set, and networking is one of those foundational area. Um, and and so that's the reason that we thought that it's really important that we bring in actually a series to help people start thinking about some of the core concepts of networking, which is what Imran and Imad is going to cover today. But then we will start to gradually build on top of it. So if you go, Imran, to on the next slide, we have a bunch of sessions that we have planned. So starting with just basic concept of, hey, what is VPC? What is a virtual private cloud? look like? How should you think about when you're setting up a VPC or subnet in AWS? And then we'll look at, as you grow, as your needs grow, how do you have multiple VPCs? You might be operating in multiple countries. How should you structure your network accordingly? How should you connect those networks within AWS? Then a lot of our enterprise customers like Mercury, for example, often have a need where they need to connect their on-premises environment with AWS. And that's where we're going to look at how do you build resilient hybrid connectivity with AWS. And on that, in fact, in a moment, I've got an interesting announcement to make, which I'll jump onto soon. But so that's the series. We're gonna then talk about some of the network optimization tips and best practices. We recently did a blog on that topic, and there was a lot of interest in terms of getting some prescriptive guidance from AWS about how do they go about optimizing the network in terms of security, performance, and all those well-architected pillars. And then finally, last of that is about the whole security aspect. We have a number of customers talking to us about centralizing ingress, centralizing egress, with traffic inspection and monitoring. So we will cover some of the network firewall deployment strategies. Though we'll focus on AWS network firewall, we'll definitely talk about if a customer has any other firewall appliance like Checkpoint and Palo Alto, or any of those appliances, and how do you go and deploy into a VPC and do centralized inspection. So that's the plan.
That sounds awesome. And it's every 2 weeks, right? So this is the first one, and in 2 weeks we're going to be doing the next one, and then the 2 weeks the next one after that.
Absolutely. So yeah, so from next week, I think, because of the daylight savings, we're gonna so next fortnight, the next session will be starting at 11 to 12, correct, Casey?
Yes, that's New Zealand time. So
Yes.
just an hour earlier, so to speak.
Absolutely.
Yeah.
Cool. So as I mentioned about the hybrid connectivity aspect, I've got one quick announcement to make before I hand it over to Imran, is we now have got finally a Direct Connect POP in New Zealand. Hooray!
Yay.
This is something that
It
I
has been-
remember many of our customers have been asking us, when is it coming? When is it coming? So here it is. It's finally here. What it means is that if any of the customers want to connect their network or on-premises environment with AWS, it's going to be significantly more easier as well as cheaper to connect their network. This takes away the whole trans-Tasman connectivity cost that many of the customers have to pay. I know some of the customers with a 10 gig link to Sydney were paying about $50K a month or something like that. This will bring it down to zero, especially if you are present in the Direct Connect POP location. We're going to be in Datacom Orbit, which is a location where we know that number of our Direct Connect partners are present, as well as number of our customers have presence in Datacom Orbit. So it's a truly exciting thing for us. It's a part of our plan to bring or land more and more infrastructure closer to our customers in New Zealand. We soon, as you might have seen, announcements about local zone. So local zone is expected to come soon in Auckland, and then of course the plan for the region, full-fledged region with multiple availability zones coming in 2024.
Awesome news, Imran.
Yeah, someone did ask, where's the next place you would like to have a Direct Connect location? So that is an interesting question. Is that like posed at us, as in like where would we want another Direct Connect connection in New Zealand, or like just generally in the world?
Right. Look, I mean, in terms of where would that be next? It's always dependent on what's the customer's ask is. At AWS, every investment decision that we make is based upon the ask from our customers. So as I said that about New Zealand, there has been an ask from number of customers running hybrid workloads. And in fact, including Mercury, Imad has asked us a few times about some of this. So yeah, next location will be entirely dependent on what our customers are asking us for.
And always give feedback to your account team or to the AWS team that you see around. Even if you're not a customer, just give us feedback. At worst, we would, well, I should say at worst, it will create a positive outcome like this.
Awesome. Okay, with that out of the way, let's get started with AWS Networking Foundation. Once again, I welcome everyone who has taken time to join us in this series. All these recordings are going to be available post a session on demand for a few weeks, so you can absolutely tune in, or on our From the Field YouTube channel as well.
All right, shall we get into it?
Cool. All right. So I'll get started on the first session for the series, which is AWS Networking Foundations. And as Rathan mentioned and highlighted a really good point that in nowadays, even if you're not a networking specialist and you are a developer or anyone else working in the cloud, you should have the foundational knowledge of networking because it makes the basis for everything else. And that's the purpose of today's session, is to introduce those basic concepts and take you through some of those. Cool. So we're trying to make it a bit more interactive and fun way of introducing these concepts rather than just taking you through slides and mentioning each of the features. We thought it'd be good to talk about a fictitious company, example.com, and their networking journey. So in terms of what that is, it's a first user of AWS. It's a company which has a lot of on-premise hardware and which is coming out of end of life cycle, and they need to renew or buy new hardware. So one of the CTOs attended a recent AWS event, something like this maybe, and they decided, hey, let's give this a go and see how one of our web applications running in AWS will look like, so that he doesn't have to spend a lot of capex money in buying new hardware. So that's what we were trying to present today from that perspective. So on that, I mean, we have Emad over here. We're talking about the journey into networking. So I'll probably pose a question to Emad, how his networking journey has been, because as Rathan mentioned as well, he is the actual networking guru. We are just, we just like networking, but we're not the actual networking gurus. So Emad, over to you.
Hey, thanks, Imran. Thanks for that. Look, my experience of cloud networking was amazing. So initially, everything used to be on-prem, and building a campus or a site requires those switches configured, routers to be configured. All those sorts of things take time. So the first experience I had moving, workloads and creating a VPC to begin with was amazing. I could stand up the VPC, and just in a test environment, I was able to put a EC2 instance with a Hello World web page in there, literally in about 20-30 minutes of time. So that was really amazing. So traditionally speaking, that takes quite a while. So we started from there, and then we started doing non-prod, and then essentially moved towards prod and so on. So the entire journey, if you compare it time-wise and probably flexibility, scalability, and all that, it was amazing. So the journey was amazing. So I think it's not one factor, I would say, that is making me say it's amazing. It's not just cost, or it's not just time. It's a combination of all sorts of things. So yeah, I would say it was a pretty good journey. Technically, it's easier.
Oh, thanks for that. Yeah, I think the agility is what strikes me as well. And same with my own personal experience, even before when I joined AWS, when it started playing around with that. Yes, it's the agility and the speed that you could bring those things up in cloud compared to when we had to do it on-prem. It used to take a long time, specifically when you talk about networking, right? So cool. All right. Well, before I get into the foundations part of it, I thought at very high level, we'll talk about AWS's physical infrastructure, right? So at very high level concept, we have the region that Rathan mentioned as well. So region are basically distinct geographical locations around the world for AWS. And each region is designed to be independent in terms of it doesn't share any networking dependency or other service dependencies with other regions as such, so that you can deploy your applications in a region with all the confidence that it will, first of all, live in there, but secondly, all the resources it requires are dependent and built into that region itself. So on that, we do have an announcement that a new region will be coming to New Zealand in 2024. So very excited and looking forward to that. So each region is,
in fact, just on that, that will be third region in ANZ space. We recently went live with Melbourne. So Australia now has got 2 regions, and Auckland launching gives our customers another option to to deploy applications, and where necessary build multi-region deployments. In some scenarios and some use cases, we have heard customers have that need, and that's why we're responding with multiple regions in Australia.
It's a good point. And the Sydney region's been there for almost 10 years now. And so it was quite excited to have the Melbourne region launched last month. Now, so within each region, we have availability zones. Availability zones, again, are distinct locations within a region. They are far apart enough that they don't affect each other in terms of service outages. So something that we talk about is fault isolation boundaries, and we built our services around those boundaries. So availability zone is one of those boundaries, meaning that they have redundant power, redundant networking, redundant cooling, so that if something happens to one of the regions, it doesn't affect, something happens to one of the availability zones, it doesn't affect the other availability zone. And each availability zone, can be made out of multiple data center or physical buildings themselves. And in AWS's architecture, currently, we require at least minimum of three availability zones in a single region. So when the New Zealand region would be launched, it will have 3 availability zones, as it did with Melbourne. And then as I mentioned, with each availability zones, you have different data centers, and each data center will have the standard racks and host and everything else configured in there. Cool. So that's the basics out of the way.
If there's a question that comes through, is there extra cost for regional traffic, for cross-regional traffic?
So, as you know, the ingestion of traffic is free with AWS, but when you are egressing traffic, there is cost involved in there. So if you're going from one region to another, yes, there is cost involved. Cool. So let's talk about VPCs. So going back to our story in terms of example.com. So Jimmy, who is the network engineer at example.com, he's been given the task to set up AWS networking. And first thing he does is he creates an account, and that gives him a default VPC, which is a virtual private cloud. And it's a isolated networking environment within an account for a customer, where they can go and set up their own networking, and they can decide on how networking is operated within that. And when you set up or when you out of the box, you'll get a default VPC, which will be spanned across multiple availability zones. In this case, we are highlighting US East 1A and US East 1B. Let me just get the cursor so we can see that. So 1A and 1B, and then there would be a subnet that will be, or a CIDR range, which will be spread across those availability zones. And you would then go and chop out that CIDR block and give it different subnets for each of the areas that would be designed in those availability zones. So a question. Yep, go on, Casey.
Quick question. What is a CIDR range? I'm assuming it's not the soft drink.
No. Again, Emad will probably correct me, but I think it's classless inter-domain routing. Oh, got that right.
Yeah,
okay, cool.
You got it absolutely spot on.
So I'll probably pose a question to Emad and Ratan, and there is like, what considerations that you would make when you're deciding on what CIDR range you should be putting in your VPC?
Yeah, if it's me, I would say there's depending on the environment, such as the number one would be, I would want to avoid any overlappings with any of the existing IP ranges or CIDR blocks that I've got. The other would be the size, depending on, again, there's no single answer. Like someone would want to keep according to the environment, a bigger size of the cider block, while depending on the requirement, the size should be smaller. So those kind of things are really important, looking at your environment and carefully deciding what sort of a cider size you need for a VPC. So otherwise you end up into a lot of problems, because if you want to expand that later on, then that's a lot of work. So thinking about it in advance is probably fundamental factors I would consider designing a VPC. Subnet length, ciders, so picking up subnets, picking up in a way that it does have availability zones and so on. So all those things like availability zone A, B, and probably C if you want to go with more high availability. So those kind of things are really important. These are the fundamental blocks. The moment you start putting workloads in there and you don't carefully design the VPC, then that's a bit of a nightmare managing them afterwards. So you don't do it before.
And especially if you end up in a situation where you have, overlapping cider range, I think that's the most painful thing that probably the nightmare for network engineers to deal with, right?
Yes, that is true.
So I think one of the key criteria, I guess, would be to, at all costs, as much as possible, avoid, overlapping cider ranges, not just within AWS, but also between your on-prem and AWS environment. So carefully think about which range you want to use there versus, what you're using on-prem.
So in layman's terms, if I get this correct, so a cider range is just really a range of IPs, and you want to make sure that you're not overlapping that on any of the systems that you're utilizing.
Totally.
Yeah.
And it essentially decides the number of IP addresses that you can have. The size, so /16 on that screen that Imran just had, means that you can have over 65,000 IP address. It is 2 raised to power 16. So it's the size of it is about how many addressable, IP addresses that you can have within your network.
Correct.
One of the other,
sorry, go for it.
Sorry, go on. I was just talking while Ratan was mentioning around 65,000 IP addresses. We recently increased the number of IP addresses that you can have in a single availability zone. I think it's gone to 256,000 now. So you can have multiple cider ranges in there.
Yep.
Sorry,
you could definitely add additional cider ranges to your VPC. So extending that is not such a problem. It's not such a big drama. But there are a few other things, as we were discussing earlier, which is about overlapping cider ranges is a big problem.
Yep. And another question came through: if you have a container platform like EKS or just containers, and I guess this also would apply to Lambda, where the containers are ephemeral and I have a /17 cider range, what is the best options for ensuring I always have IP addresses for new containers?
I think one of the other factors is when you're trying to connect it to on-prem, you also have to consider your on-prem environment. So there's no overlapping there. So not just in your cloud, with your on-prem, you might have to consider that how the routing should be done, and are these cider blocks unique or not. Those are really important factors as well.
Cool. So coming back to the question, Casey, yes, we have seen that with customers, they normally assign additional cider ranges for the EKS workloads specifically. And there is actually a solution available. I'll probably post a link afterwards that you can implement to monitor the free available IP addresses in your VPC as well. And that sometimes you have seen customers do that. So they will send an alarm if it drops down less than 100, for example, available IP addresses. So yeah, if you have a EKS cluster, you can, as mentioned, have additional cider ranges. So you can have up to 256,000 available IPs in there. So I think if you're going above that, then obviously you have very, very large workloads, and there are other mechanisms and architecture patterns that you can use.
Yeah. And the other consideration that I would like to add to that is that think about that. Does all your containers need to sit inside one big subnet or one big VPC? We do, if you're taking a microservices based approach, think about, can they be in a different subnets? Can they be in a different VPC altogether? So you got to have a very good reason that all the containers are actually deployed inside a single VPC, or a single subnet. /17 is a pretty big range anyway.
Usually, sorry. Usually, what I've seen is that it's divided between application databases and so on. So you pick up the subnets accordingly, and that's much more and much more easier to manage if you put it that way.
Cool. All right. So moving on. This is really good question. So thanks for that, and thanks Ratan and Imad for jumping in as well. So in terms of going back to our example.com, and Jimmy is setting up a new VPC. He set up the CIDR range, or by default that comes in, and he carved that out into different subnets. So 172.31/16 will be divided up into /24 subnets for each one of those 4 subnets, and that's what you need to do when you're setting up the VPC itself in there. So now Jimmy's gone, and once he's got the networking set up, he's handed that off to his development teams, who has gone in and set up the instances in each of those subnets. And obviously, we'll talk about what the distinction is between different types of subnets. But usually you will use subnets for putting your workloads. It could be instances, containers, or it could be anything else in there.
Can you net between those workloads and instances?
Internal NAT. Yes, there are ways for doing that, but by default, when you set up the subnet and VPCs, the routing is enabled such that you can get to any of the subnets from one to the other using internal routing. But you would want to look at your use case and why you're trying to do that, right?
I think more context on that question would help. Yeah.
Yeah, essentially, if you're looking for just the default stuff put in there, there's no like one simple way. But if there's a use case, for example, if you really want to net it, you might want to pass it through such as a firewall, net it, or a device, or custom net device that can do it.
And that's a really good point. So one of the sessions that we have listed in our upcoming sessions, the last one around firewalling in AWS, that would cover that part for you. So we've gotten Jimmy. Jimmy's gotten to the stage where he's got the instances deployed in there in the subnets, and he's got the IP addresses assigned and everything. But now his developers have servers which require external access to some external API endpoints where they want to get some data from, and he's come to a situation where he needs to enable internet access for those instances. So I guess the question I'm going to pose to Imad, being, let's assume you're Jimmy, what do you need to do to enable internet access out of those instances?
Well, it totally depends where the instance is. For example, if the instance is on a public subnet, you can just attach to a public IP using internet gateway, and that should do the job. And if it's a private subnet-based instance, then that can sit behind a NAT gateway, and then it will have outbound internet access, which is public internet access. So there's, again, according to the use cases, there are several ways. For inbound, it does not necessarily need to be directly on a public IP address. It can sit behind a load balancer as well. So all those methods, depending on the direction of the flow, such as inbound or outbound, there is different and multiple ways how you can deploy an instance with an internet access.
Cool. All right. So we'll cover all those. So that's a really good answer on that, Imad. So we'll cover all the scenarios and what to do. So in this first instance, we just need to enable public internet access from the instance itself. And in AWS's realm, when you're setting up VPC and you want to allow internet access, there are a few things that you need to set up. So it needs to have a public IP address, for the routing to come back as well. You need to have internet gateway attached to your VPC. So the internet gateway is a virtual appliance which lets you route traffic to the internet from a VPC. You need to then add it out for your subnets to send internet traffic to the internet gateway. And then the other two security parameters that you need to set up is network access control list in your subnet itself to allow outbound access, and your security group, which gets assigned to an instance to allow outbound access as well. So we'll cover each one of those as we go through, but these are the things that Jamie would need to go and set up and make sure are there for the internet access to be available. So if you go through first one, which is a public IP addressing, so if you have a subnet and instances, you can assign public IP addresses to your instances. Now, how do you assign public IP addresses in AWS's one, right? So there are different ways. One is you can use an auto assigned public IP address, which is just the default one which AWS will assign to you, and you can use it on a temporary basis to allow access to and from your instance. The other one is elastic IP addresses. So elastic IP addresses are on a permanent basis, in the sense that you can, as a customer, choose an IP address out of the Amazon's elastic IP address pool, public IP address pool, and that will be assigned to your account for the duration of the account. So as long as you have AWS account enabled, you will have, or you will own that IP address itself. But the second option is where you can bring your own IP address as well. So if you are migrating a workload as it is, lifting and shifting, and you need to make sure that workload or instance or container still keeps using that public IP addresses, because you might have requirements with other vendors who are whitelisting that IP address, you can bring that along into AWS as well and still keep using that.
Imran, what would cause the auto-assigned IP to change?
So one is if you shut down an instance and then start it up during that time, again, because it's assigned from a pool of IP addresses and it's temporary, there could be another instance that will spun up and requires the public IP, and that will be assigned to that one then. So if you are using a temporary and not using an elastic public IP address, then there's a chance that it can get reassigned to someone else. So you got to make sure that if you have a requirement for a permanent public IP address where you're bounding a DNS or giving it to other customers, you want to use an elastic IP address. And it's a funny thing. I've seen that with customers in the past, where they would have just spun up an instance and assigned a public, one of the temporary public IP addresses, and then they would have set up their DNS to point to that as well. And then 6 months after that happening, they've shut down the instance for maintenance or whatever the reason is, and that temporary public IP address is taken away from them. So that's a really good point, and you should watch out for that.
Also, are we covering VPNs in this chat?
No, so the connectivity that we talked about in the next session, that will cover that.
Yeah, Hartstead, I would say that I'd highly recommend you catch the next show in 2 weeks, because we'll go over the connectivity aspect and networking. And this is the exact type of show and reason why we're planning to give this series. If people don't know a lot about networking, we really want to start from the basics and then work our way through to that more complex stuff. So just keep joining us every 2 weeks for the series. By the end of it, you'll be a networking ninja, as Ratan would put it.
Great. So going on our theme of allowing public access, the second one is internet gateway, as I talked about. So you need to have an internet gateway attached to your VPC. So it's a virtual appliance that gets attached to your VPC. So Jimmy would go and attach it, and that will allow you to pass the traffic to the internet from your VPC. As I said, the whole concept of VPC is your own virtual cloud in AWS, and gives you total control of how you want to set up. So including things like how would you configure internet access. And once you have the internet gateway, you still need to actually enable the subnets to route to the internet. So in this case, for our public subnet, where our instances are sitting, we will then add a route for 0.0.0, which is the internet, to be going to the internet gateway that you would have assigned in there. Whereas compare that to the instances sitting in our private subnets, they do not have direct access to the internet. And if you look at that route table, it only has the default route, which is within that VPC subnet. So they can't get to outside world. Now, while we're talking about the gateways and we talked about the private subnets, and Imad mentioned that before as well, if you have your instances sitting in the private subnet, and that could be your application servers, you don't want direct access to internet for those instances for security reasons, and neither they should, unless there's a really good use case. And how do you provide access to the internet? I mean, you also don't want to attach or keep attaching public IP addresses to those instances as well. That's where the NAT gateways come in. So NAT gateways are, again, virtual appliances that will be sitting in the public subnet and do a network address translation of your private instances that will be sitting in your private subnet. So once you enable NAT gateways, or once you deploy NAT gateways in the public subnets, it's a managed service that you can use, or if you have other requirements, you could put in your own EC2 instances and use that as a NAT gateway as well, if need be. Again,
sorry, just to jump in here, Imran. One of the best things, exercises that I tell anyone to do, whether or not done you or experienced in the cloud, is to actually build this from scratch. Don't use any of our wizards or anything like that. Just follow one of our step-by-step guides, and this will teach you essentially a lot of the foundational knowledge for networking, because you have to build the NATs, you have to build the route tables, you have to handle the public and private subnets, so having access to internet or not having access to internet, and also dealing with the auto assigning of like IPs to EC2s and that stuff. Like, this is like a really, really good just task to do. Even I do it once a year, because the amount of time that I will forget like a minor detail of this and screw myself over. It's amazing.
No, it's a really good point. And I guess that's what the point of this foundation session is as well, is to, the building blocks, what is involved in. So if you get everything out of the box and something is not working, at least you know what are the components that you need to go and check to find out what is the actual problem itself. And there is something else that can help you as well, and I'll talk about that in the end. But yeah, routing is important. You should know at least the basics of it. For private instances sitting in your private subnet, to get to the internet, they need to go through a NAT instance to get that access itself.
And Matt, do you have any perspectives on that as like someone external from AWS?
Sorry, you might want to repeat that.
In terms of having this as like a good tool to just do once a year to just make sure you're across the basics as a team member, or just someone that is a developer or whatnot.
Yeah, absolutely.
Cool. Let's move on.
All right. So now we got into a stage where we got the instances set up. Jimmy's got the internet access for his public instances as well as the private instances sitting in the private subnet. One thing that his chief security officer has always wanted to do on-prem is to provide an east-west network segregation, meaning that some application-centric networking and security, so that traffic going from one instance to another instance is controlled, and you only allow what is required between those application servers, for example. So he's asked Jimmy. Yep.
So what is east-west? If there is east-west, there must be something north-south as well, I'm guessing. Yeah.
That's a good point. I should explain that. So in terms of the network traffic flow itself, if you look at typical 3-tier web application, you will have either a load balancer or a proxy, and then you have your web servers, then you have your application servers, and then you have your database servers. So the normal traffic flow, which we say north to south, happens is starting from the very top, from the proxy or load balancer to the web server, then to the application server, and to the database servers. And in a traditional sense, on-prem, Imad can probably explain that a bit more, is that you would set up things like DMZ for the web servers, and you have your proxies sitting in there or web servers sitting in there. Then you have traditional firewalling with different subnets, and you will have allow lists and block lists in there so that the traffic can be monitored and controlled in terms of how it flows back to your database itself. Whereas the east-west traffic,
no, sorry, just to add in there. So east-west normally, in simple words, is horizontal traffic within, let's say, your environment, and north-south is primarily internet and your environment. So it's more of a vertical traffic. So depending on the requirements, the security can be put into different places where the traffic is flowing. It's more about the flow of the traffic. So if it's north-south primarily, it is referred to internet-based traffic. Now that could be both inbound and outbound. And with east-west, again, it's horizontal from, let's say, you've got two VPCs and something is flowing between the two VPCs, or something within different subnets flowing between each other. It's all considered east-west.
Yeah, it's a buzzword that I grew up listening from a lot of networking guys, and for a long time I was like, "What is this?" You know. So it took some time, and it gets referred so often in conversations, especially in the context of security discussions. So it's really important to have that understanding when you're talking to security folks or networking folks. Yeah. Thanks,
So
Imad. Thanks, Imran.
good point. Good point, Ratan, and thanks for pointing that out. So, how would Jimmy enable security in at least the network security in cloud at the very basic level? So for that, we have, I'll talk about two different things. And as you said, we have a dedicated session just on network security, and that'll come up later on. But for now, we'll talk about the basic stuff, which is security groups and network access control lists. So you can think of security groups as stateful network firewalls, meaning that you don't need to have explicit outbound rule for any inbound traffic flow or network flow itself. So when you have, so every instance or network interface attached to an EC2 instance will have a security group enabled by default. So you cannot actually have a network instance, a network interface without a security group. And by default, our security groups will allow outbound traffic, but inbound traffic has to be explicitly allowed. So everything is blocked by default. You will have to open up ports in there to say what traffic can flow through this interface onto the instance. So in our example that I'll go through later on, we, by default, you will enable HTTPS traffic 443 or HTTP traffic on port 80, and then you will do it from everywhere, from the internet into your instance. And very important point, and I've seen a lot of people not know this very well, is that security groups are actually attached to the network interfaces, not to the instance itself, even though within the console, when you go in, you can right click on the EC2 instance and modify the security groups, because majority of the time, each instance will have only one interface attached to it, meaning you go to the default security group and modify it there. But you can have use cases where you have multiple instances attached or network interfaces attached to your instances, and that's where you can set up different security group. And that's back to Casey's point, is if you go through and manually set all that up. So for example, if you don't use our NAT gateway service and you implement your own NAT instance or appliance, you would most probably have two different network interfaces, one for the private subnet to accept traffic and one for the public subnet. And then you'll have different security groups as well. So it's good to know that the security groups are actually bound to the interfaces rather than the instance itself.
Imran, one of the things I just wanted to add is a lot of people also, if they're not networking, not having a networking background, they kind of get confused with stateful and stateless. So stateful firewall essentially just track the state of the transmission. For example, if it's a three-way handshake TCP communication happening, you just have to spin up one firewall rule, and then it's automatically going to know that it's expecting a return traffic, such as a SYN, ECK, and those kind of things. So stateful firewall essentially, in a nutshell, records the state of the traffic, and you only need to put the firewall rule at one place, which is usually the point of initiation, and then it's automatically done for the return traffic. So that's the beauty about stateful firewall, that you don't have to do two rules, inbound and outbound. You just do it once, and it's there expecting the return traffic to come automatically.
Cool. Well, thanks for explaining that. I think that's quite an important point.
On that one, I've heard some interesting analogies used to explain some of that concept. And yeah, again, it's a very complex term. Sometimes people do find it confusing. So one of the ways to explain that I've heard about stateful is that, let's say if you go to a bar or something where you have a security guy at the door, you at the time of entrance, it checks you that you're right, you have got eligibility to enter. But for whatever reason, you have to come out. He kind of allows you without any pass or anything. That fine. Yes, I've seen you. I know you. You have entered. I remember you. You're good to go. So that's stateful. Like, the guy at the door is remembering your entry, and that's why it's allowing you the exit as well. Other places, like, in our AWS office, for example, at the time of entry, we have to pass, scan our pass. And at the same time, as well as the exit, you have to scan your pass, that, you need to have the exit, because it doesn't remember that you entered, and that's stateless, so it has no context of that who, and, that you entered. So I'm automatically allowing you need to scan your pass again to exit as well.
Cool.
So yeah, that's another way.
Thanks, Varadhan. So okay, moving on. I think we might be short on time, so I just want to get through this now. So yeah, security groups in terms of inbound. So if we look at in the context of how Jimmy has set everything up, we'll have our web servers sitting in the public subnet, which will accept internet traffic, and then we have private subnets, which will accept traffic from the web servers on port 8443 in the TCP. So we'll have two different security groups, one for the web servers and one for the application server group itself. So if we look at the actual rules itself in the security group, and for the web servers, you will allow traffic from anyone on port 443, whereas on the application server, you will allow traffic coming on port 8443, but rather than specifying individual IP addresses for the web servers or the whole of public subnet, you can now actually reference the security group that was created for your web server in here. And that's quite a powerful thing, in that as you add more and more web servers, and as long as you're using the same security group, you don't need to keep going and changing the security group for the application server. So it can do self-referencing as well, but you can reference other security groups within the rules itself. So that could help quite a bit. And again, it restricts the traffic that's going on to or allowed to for each of the instances itself. And the other one I talked about was the network access control list. And in here, what you do is network access control lists are stateless firewalls. And Ratan is going to really, and Imad is going to really give a good explanation of what those are. And they are bound to the actual subnets themselves. So in this example, if we look at our private subnet where our application server is sitting, by default, this is what would be set up. We'll allow everything inbound and outbound. So we don't restrict anything on the network access control list. So if you look at the left, which is the inbound rules for the private subnet network access control list, and right is the outbound one, and we're allowing everything all the time. Now, if you want to go and restrict that, so we want to say only allow traffic from our web servers or the public subnet for where our web servers are sitting, you would go and modify that. So in this case, we'll only allow traffic on port 8443 and only allow it from this subnet. So it doesn't allow access from everywhere. But again, for outbound, this should have been outbound actually. So there's a typo here. So this one is outbound. You would need to add the full port range for the outbound traffic. So because when a web server is sending traffic to the application server, it will randomly choose a port between 1024 and 65,000. So you would need to put those port ranges in there to allow the traffic back to the web server itself.
I also noticed. Yep. So I noticed that in the NACL there, you had a rule number. Like, what do those rule numbers mean? Because before it had 100, and now this one has 10. Like, how does that affect the evaluation?
Yeah. So so the priority for which rule takes precedence, because you will have some deny rules in there as well. So that numbering helps with the priority. So lower means it's high priority. So for example, if you set up a rule number 2 over here, which could be higher priority than number 10, and you put a deny on there, that'll get denied then. So
essentially it goes sequentially. So lower check gets checked first, and then on, so it goes sequentially.
Goes from there. So you can do that. So now that Jimmy has got the networking sorted, we got the security all good. We got the access to internet access, and we got the application as well. His developers is asking him, how do you make our application highly available? We don't want to have just one web server sitting in one subnet, and if it stops working, what happens to our application? So that's where Jimmy goes and looks to set up something called Elastic Load Balancer. So this is a load balancing managed service, which allows you to send traffic to multiple instances in different availability zones for you. So in this case, we will set one up, and that will send traffic to both the web servers. And what that allows us to do is have our application highly available, sitting in different availability zones. So even if one of them dies for various reasons. One of the things I mentioned before was around fault isolation boundaries. So our availability zones are designed to be around those fault isolation boundaries, and our services are designed that way so that fault in one of the availability zone doesn't get propagated into other availability zones. So having it in multiple availability zones will help with that high availability.
And also,
I do have a demo.
Just on experience, also, I find that web servers quite often their disk space gets completely maxed out with logs, and then they die and over there. So having that high availability and self-repairing infrastructure really help save your bacon when I would say really basic things like that get overlooked. And it has happened to myself when I used to manage infrastructure in the past, and it has happened to many other people as well. So especially if you're running .NET Core, it's quite a common learning hurdle, as we should put it.
Yeah, and that's very true. And by default, most of the logs sometimes just get stored on the root volume as well, right? So it's a good idea to have a separate volume and move your logs onto that, or point to that. Remember that as well. So I do have a demo, but let me just finish a couple of other things, and then we'll come back to the demo if we have time left. So last concept I wanted to introduce was around network monitoring, right? So now that we got the security in place, we got the high availability and everything, one of the things that the security team really wanted to see was if you could capture the network traffic, the flow of network traffic from each of the instances that is coming out. So traditionally, what example.com has done is on-prem, they have an agent for their networking product installed on each of the servers, and that's how they're getting all the networking logs out of that. But they don't want to be doing that as they go into this new cloud era. They want to see if there is a way of doing it without installing the agent itself and send that network traffic flow to their centralized incident and event management application or platform for security. And that's where the VPC flow logs come in. And this is a service which you can enable on the VPC, and you can enable it on the VPC, on the subnet, or even on selected Elastic network interfaces. Allows you to capture information around the traffic flow itself. And you can send the traffic to our CloudWatch service or S3, and from there it can be ingested into different tooling if need be. And it can log accepted, rejected, or all the traffic that's being generated from the instances for you. So it's a really powerful tool of knowing what is going out of the instances and what is coming out of it, as well as within your network to determine things like if there's a data exfiltration is happening, or if there's a compromised instance which is sending traffic to unknown addresses, for example. And lastly, so Jimmy set all that up, and one thing his security team notices that one of the instances now generating some suspicious traffic. So what they have asked Jimmy is to see how we can capture the actual network traffic, the traffic packets out of that instance, so they can do a further analysis on that. And for that, he is looking to use something called VPC traffic mirroring. And what it does is allows you to mirror traffic for interfaces or instances as it is onto somewhere where you can actually then inspect it deeply, what data is actually being sent out of those part of the data packets. One thing to notice with VPC traffic mirroring, if you are setting this up, is that the packet copy shares the interface bandwidth. So Elastic Network interface that you've selected or set up on the instances, just make sure it's got enough bandwidth in there to do that for you. And you can set up, mirror filters when you're putting that mirroring as well, so you don't need to capture every single thing. But it allows you to configure those things. And here I had one last question for Imad, which was around what his experience been with traffic mirroring. I know that he's mentioned that to me in the past, that they have used this feature. So I would like to hear what is the real use case that you have come across.
Well, I simply loved it, and there's a couple of reasons why.
You've muted yourself.
Oops, sorry about that. So what I was saying is, in traditional network, it's kind of really complex. The moment you want to do port mirroring beyond a physical boundary, so such as remote span, ER span, and all those kind of things, they require a little bit of more routing, and they're a little bit more complex. Whereas the VPC mirroring over here, it's quite simple, it's quite easy. So you can just consume a service, attach it to an interface, and bang, it's all good. The filtering option on top of it was really, really good. So my experience was everything was set up in no time, and I was able to filter the traffic right there at one dashboard. It's you're doing not just mirroring, you're also filtering traffic, so you're picking up only the right amount of traffic that you would like. So it's pretty awesome and pretty simple.
Cool. Thanks for that. It's good to hear some real use cases for it.
Sorry,
lastly,
just to add, the number one use case that I see from security point of view is people want to attach it to their SIEM or whatever, their security appliances. Either it could be native, they might be doing something through Athena, or it could be something which is like native to their environment, such as a SIEM, which is a third-party platform. Cool.
Yep.
I'll just let you continue.
So this is just some other concepts in networking. Again, part of the basics and foundations, which I think everyone should know and be aware of, that they are there. It just makes your life a lot easier. So one of the things that Casey mentioned is, if you go and set up everything manually in a VPC, and once you configure everything, there's always something that you might miss, and you wouldn't know why the traffic is not flowing, or why your instance can't get to the internet, or you can't access one instance from another one. And that's where one of those services called Network Reachability Analyzer comes in really handy. You can run that, specify the source and destination IP addresses within your VPC or even outside, and it gives you a really good network flow of what is happening with the traffic. So if there are any security groups set up, if there are NACL set up, it'll go and list all those out for you. So that's a really good one to use for diagnosis purposes. And then we have IPAM, which is IP address management. So as the organization grows, you want to know which IP addresses is assigned to which workloads. So that's another way of managing that. And then there's managed prefix lists, which is dedicated prefix lists for different subnets or different CIDR blocks, so that you can refer to them from within your AWS accounts for cross VPC reference, as well as within the VPC and the account as well. It just makes it easy, more human readable, rather than remembering all the IP addresses or the subnet ranges themselves. Cool. Okay, so that's all I had. I know we're running very tight on time, so just put that in there.
We don't actually have anything scheduled after this, so we can run a little bit over.
Cool.
If
that's good to know.
do a demo, because I think it would be quite worthwhile.
Yeah, nice. Okay, cool. That's good. So we'll get back to the demo then.
And if you have any questions, this is the best time to ask.
Cool. Let's jump into demo, Imran, just quickly of how to set up VPC and some of the subnets.
Yeah, so there are different ways of doing that, right? One is you log into the console and do that there. So let me plug that in. I have that here. So if I go to another VPC dashboard, so one way of doing that is manually, right? So you go into our EC2 console and you go to the VPC, and then you create a VPC. And you will be given different options in there. On the right-hand side, you will get a preview of what you're setting up. You can do the tagging of the VPC, the CIDR block that we talked about before. So this would be /16, or it could be further reduced if need be. You can use IPv6 as well. We do have that available if need be. And then number of availability zones, by default, you get 2. But again, if your application needs to be very highly available and you need to have more availability zones, you can set up 3 of them. Number of public and private subnets. Again, what this will do is set up the internet gateway and internet gateway attachment and the routing that we talked about before in our earlier slides. So it will do that based on what type of subnets you're setting up. In here, again, you can customize the CIDR blocks. Were you about to say something, Rapan?
No, I was just saying that, Imad, I don't know when was the last time you probably looked at the console, because I know lots of our customers use completely automated tools like CloudFormation and Terraform to build this. But this is a new VPC wizard that came, I don't know, probably last year at some stage. I quite like it because of the visual representation that it gives on the side of what you're doing.
I've used this one, not in the production environment, but in the sandbox environment. I've used this and liked it quite a lot.
It makes it so much easier, like so much easier.
Yeah.
It does, doesn't it? Yeah, I know. I remember the old days as well. It used to get quite difficult. But yeah, this is really easy to go and configure and customize as well at the same time, right? And then lastly, the NAT gateways, which again, you can have one in an AZ, or you can have one per AZ, meaning that if you do just one in AZ, even if you have 3 availability zones set up, you'll have one NAT gateway virtual device. And even though everything will work fine, but it just have the risk of, if that particular AZ where you configured NAT gateway goes down for whatever reason, your instances won't have internet access. So what we do is we ask our well, if you are setting up, just try to set it up for your production accounts at least one per AZ rather than just one in the whole environment VPC. And then there are endpoints we can talk about in further sessions, but basically endpoints allow you to have use AWS's private network to get to AWS's services. So S3, for example, is our public service, but rather than going over the internet to access it, you can use endpoints to directly privately access that service. And then there's DNS resolution and all that happens. So you can create it, it'll go through. So that's one way of doing it. But my preferred way, very opinionated, is using automated tools.
Here comes the hidden developer side of.
I am not a developer. Far from it.
Zoom in.
So let me see if I can.
And also now everyone can judge your coding.
Yeah, don't not judge me. Yeah. How do I zoom in? If you can zoom in.
I think it's readable anyway.
It's readable to me.
It's readable.
Okay.
So go ahead.
Yeah.
So this is something called AWS CDK, which is Cloud Development Kit. If you haven't come across that, what it does is it allows you to codify all of your deployments for infrastructure. And you can do it in your own preferred language. So you can use it in TypeScript, Java, .NET as well. And it just simplifies the whole process a lot more. I mean, we've gone through the wizard as I showed you before. There's a lot of things that you can configure in there. But here you can do the whole thing in just 2 or 3 lines. You don't even need to specify the max AZs and NAT gateways and all that. So basically, we just construct a VPC, give it the name, IP CIDR range that you want to specify, how many AZs you want that to be in, how many NAT gateways you want, and the name of the VPC. Just very, very simple way of doing it. But what it does allow you to do it, so in our example, for the example.com customer, so they have set up everything in one region. Now they have set up their non-production environment and they want to repeat the same thing for their production environment. and you want it to be consistent across environments. Obviously, you would change like the CIDR ranges, but in terms of the setup, you want it to be consistent so that you don't get any surprises when you put things in the workload. So this automation or having everything codified helps you do that rather than manually going in Kenyan. So I will highly recommend that you look into, and if you don't want to do CDK, look into CloudFormation or Terraform or any other programming language or any other your preferred scripting language. Use that.
And
so what
also for a quick note there, for infrastructure as code, you tend to will have two layers, your persistence layer and your non-persistent, which will be your applications. Like your whole networking stuff, you don't really want to include it in the same stack, because the last thing you want is someone to delete an application, there goes all your networking. It generally ends very badly. So you generally will have two different stacks, or infrastructure as code like components. You'll have your infrastructure component that will handle all your networking and all this and subnets and stuff like that. And then you'll have stuff that builds on top of that, and reference those subnets and network assets.
Yeah, that's a really good point. And you would set up different pipelines for that as well. So you have your infrastructure pipeline, and then you have your application pipeline on top of it. So what I've done in this example, I mean, other than just setting up the VPC itself, I'll take you to the console. What I've done over here, if you scroll down a bit, is I've set up the application as well. Again, qualifying it just makes it a lot easier. So I've set up a auto scaling group. We can talk about auto scaling groups later on as well. For the public, the private, and I mean, I won't go into any of that, but basically what this is doing is setting up this one. If you go back to our web, yeah. So basically, that's what it is setting up. It's setting up your load balancer, setting up the VPC, setting up the web servers, the application servers, and everything. So the application server that I've done or deployed is very simple. So if I go into, so let me take you through the VPC itself first, right? So what that is, on how it's configured. So based on that code, what it is done is it set up a VPC for you. So I've chosen it. It's called my default VPC. And as you can see, it's got 4 different subnets it has set up with different CIDR ranges on the right. So there's private subnet, 2 private subnets, and then 2 public subnets themselves. So some of the concept that we wanted to talk about was like the route table, which is attached to the subnets, right? So if I look at the private subnet, it's got the default route, which gets added in by default for your local VPC CIDR range, but then it has one to get to the internet itself or to any range, and that's where the NAT gateway comes in. So it's pointing to the NAT gateway. And if you go on the left-hand side, you can go to NAT gateways over here, and you will see we got 2 different NAT gateways set up, one for each availability zone, and they're both sitting in the public. So coming back to the subnets, if you look at the public subnets route table, you would see it's not pointing to the NAT gateway. So it's going directly to our internet gateway, which is attached to our VPC itself.
And I'm going to say that this awesome feature I just noticed that you're using. So you can filter the whole entire toolbar by the VPC in that top left area. That makes my life so much easier. And I don't know why I don't know about that. Cool.
There you go. You learn
Learning
something
every day.
Yeah. Yeah, if you have quite a lot of VPCs in your account, yeah, they can be quite painful. So this is really good. The other one we talked about was the network access controls. I'll talk about the security groups anyway later on, but this is the network access control list. So on our public subnet, we'll have one for inbound, and we have for outbound 2 separate ones. Again, this is stateless, so you would need to configure rules for inbound as well as outbound traffic out of that. So we got a whole lot. As you can see, this list on the left is just grown by so much, right? I remember when we started, there were very few, and now we just got the VPC, we got the security aspects, we talked about the ACLs and security groups, we got the DNS firewall, network firewall, VPNs, verified access, a new service again, transit gateway. So we'll in the further sessions that'll come up, we'll talk about each of those different parts, but it is quite extensive, shall I say.
Sweet. I think that this is also a good time to wrap it up, Imran. So I do think that I do thank everyone that has come on, like yourself, Ratan, and also Imad as a customer coming on and helping share his knowledge. So thank you very much for everyone that's for taking your time out of your day to do this, and also our viewers. It's awesome having you here, and also thanks for all the interaction. Ratan, do you want to just finish off with that great news for anyone that happens to be in New Zealand?
Yeah, so look, I mean, at the start, I don't know if at what stage you joined in, but we mentioned about that we have launched AWS Direct Connect. So it's finally in Auckland, New Zealand. It simply means that you can connect your on-premises environment with AWS much more easily, quickly, as well as more cost effectively. So if you're interacting with your account teams, reach out to them, talk to them about how they can help you get your on-premises environment connected with AWS using AWS Direct Connect POP location in Auckland.
Cool.
Additionally, we do have, as I said, this is a series that we are doing on Networking Ninja, helping you become one, hopefully throughout the series. So we covered networking foundation. The next in the series is understanding how do you build a multi VPC architecture and building connectivity between those VPCs. So this is the topic which we're going to cover in the next session. So feel free to join us at 11 to 12 in 2 weeks' time. Right, Casey?
Yeah, that's New Zealand time as well. Remember, we are global, so you have to do preference everything,
Yes.
and so it in the New Zealand time. Outfits, he said, does it include island services? So that's a POP for Auckland, New Zealand. Ireland will have its own POP location or set of circuits around Direct Connect. So just reach out to your account team, or put something in the contact us form on the AWS site, and someone will be in contact for you. With that, we do need to jump off. Thank you, everyone, for your time.
Thank you so
Awesome.
much.
Thank you, everyone.
Thank
you all. Thank
Thanks
you
for
so
joining
much
us.
for inviting
See
me.
ya.
Thank you all. Cheers.
Thank you,
Bye-bye.
Emma. Thanks for being
Okay.
here. Cheers.
See you. Bye.